Hi guys, Noah here. It is Thursday, July 19th, and we are here for our third session together to discuss the ACT math section. There's a chance you aren't able to see my face, but hopefully you can see this PowerPoint, and we will walk through it together. So in the interest of time, I'm going to try and point out similarities and differences between the ACT and the SAT. But I'm not going for some of the concepts like pin and back solving that are the same on both tests. I'm not going to go into the same depth as I did the first time around. So let's jump right in. So the ACT math test always appears after the ACT English test. That means that it's the second portion of the exam that the student's going to see. There's 60 multiple choice questions in this one section, and it takes 60 minutes to do the entire section. Unlike the SAT and unlike the rest of the problems on the ACT, for the ACT math section, you are given 5 choices instead of 4. So that does change some of the math in terms of randomly guessing. You have less of a chance of getting the answer correct now as opposed to the SAT. Unlike the SAT, which sort of has we have 35% of this subject, the ACT is far more rigid in its formula and in its composition. There are 14 pre-algebra questions, 10 elementary algebra questions, 9 intermediate algebra questions, 14 with plane geometry, 9 dealing with coordinate geometry, and 4 trig questions. Officially, according to the ACT, math questions are not arranged in order of difficulty, but rather they progress somewhat like the list on the last slide. In other words, when they were taught at school. So if we go back to this slide, you're going from pre-algebra all the way to trigonometry. So this is basically middle school math through algebra 2 or the beginning of pre-calculus. So in that sense, it isn't necessarily as easy to rely on of like, oh, if number 32 is easy on the ACT, it's not necessarily the same comparison as with the SAT. But that said, some students might find the later questions easier simply because those are the questions that they will have covered in their own, in their regular courses around the time of taking the test. Typically, ACT questions are straightforward. They get right to the number crunching and right to the math they want you to do. The questions may be long, but they are usually less difficult to decipher. Whereas the the SAT rather focuses on sort of real world applications and multi-step problem solving. So the SAT is asking for you to typically take more steps in translating what the question is asking in order to determine what to do. Whereas the ACT, though sometimes there are more words, is giving you a more straightforward mathematical process to figure out. Neither test penalizes for an incorrect answer. So every single answer the student should always be guessing in the worst case scenario. In terms of their structure, the ACT math section is second, whereas the SAT math section are the third and fourth sections. The ACT gives you 5 multiple choice options, whereas the SAT gives you 4. And the ACT also has no grid in. And when you look at the math with the times, the ACT gives a minute a problem, and you can use a calculator throughout the section. Whereas the SAT gives about a minute and a quarter with the calculator and about a minute and a half without one. So typically, the general rub of the ACT is that it is a more time-pressured test. And we see that here with the math. Both tests do put the largest emphasis on algebra, but the ACT tests a couple concepts that the SAT doesn't focus on as much or cover at all. For example, geometry is a significantly larger portion of the ACT, whereas it's only, it's a very slight amount to the SAT. The ACT puts a slightly larger emphasis on trig, but not nearly as much as geometry. And the ACT tests a few concepts that the SAT doesn't really look at all, which are matrices and graphs of trig functions and logarithms. And similar to the SAT, these additional topics that this test covers usually aren't getting into the knuckle busting nitty gritty. It's really that they're flashing these concepts in front of the student, and if the student has a working knowledge of how the addition of logarithms or something like that, how those combine, then they should be good to go. If you are in a position where you're helping a student determine which is their strong suit, ideally you're giving them a smart aleck diagnostic or something of that sort. But typically, if the student is good at algebra and is good at data analysis, so looking at graphs and all of those real world applications, then typically the SAT is what they should go with. If they are more comfortable with trig and sort of the upper level concepts and geometry, and they're really not so crazy about algebra, then the ACT gives more of a spread. Another important difference is that the SAT gives a formula table, which is rarely ever needed, whereas the ACT doesn't give a formula sheet, and there's an expectation that there are certain formulas that the student should know and just outward memorize. And we will address those as we go through each of the content topics. Another thing to consider when helping a student choose which test is best is that the ACT is only one of 4 sections, whereas on the SAT, it's 2 of the 4 total sections. Another important difference is that, unlike on the SAT, you can't assume that geometric figures on the ACT will be drawn to scale. In this case, they will say it explicitly. Now, there have been times where there is something that isn't drawn to scale, but again, if it says it's an acute angle and it looks acute, you can sort of guesstimate and use those strategies, but it's less foolproof compared to its SAT counterpart. So sort of a difficult thing to negotiate in helping a student determine which is the right test for him or her is that typically math, high-achieving math students prefer the ACT questions because they are they're harder yet more recent. So they're fresher in the student's mind, and those upper-level concepts are not being tested in a particularly rigorous way. But at the same time, the ACT math section makes up less of the overall test, which is also a benefit to a weaker math student, because if to a certain degree the student is claiming that they're going to do horribly on math, then there is the benefit of trying to minimize the damage that the math section can do, which is significantly less damage on the ACT than on the SAT. In my experience, it typically comes down to the other sections of the ACT and SAT that help determine where the student is at. And a lot of the time it comes down to the science section. If the student isn't into science at all and isn't particularly strong at reading comprehension, which should be evident from the other sections on it, then typically the ACT isn't going to be ideal, because the science section, as we'll see next week, is sort of this weird amalgamation of all the other sections, and it's, in my experience, the hardest to really prep a student for, because it's not content-based. It's really just about getting information out as quickly as possible from the sections. So since the math section of the SAT, or the ACT rather, is all calculator, it's worth discussing some calculator strategies. Again, it isn't anything life-changing, but the problem is that a lot of students these days are over-dependent on their calculators, and the test makers are aware of that, and so they like to phrase questions in ways that if the student is too reliant on the calculator, they'll plug in the first numbers they'll see, and they'll get an answer that's one of the options, but it will be the incorrect one. So the strategies that I've seen, if you spell it out for the kid, read the question carefully, decide on what path you want to take, figure out your strategy, write down whatever equations you need to use, and then use the calculator. And an example of a question I was talking about is the integer 60 is 20% of which of the following numbers. If a student is too reliant on his calculator, he's going to type in 60 times 0.2, boom, that's 12. The answer's A. And in this case, that would be incorrect. So coming up with a strategy for calculators, is helpful to reinforce the reading comprehension aspect of these tests. Although the calculator is allowed, if a student's punching in a lot of numbers, they're probably going about it the wrong way. Though the calculator is allowed, they really are rarely required or necessary. They make life easier, but one should be able to do the math without calculators. If a student is typing away too much, there is probably a pattern or rule that they are missing. And the problem right here is a good example. If you have a sequence of 1 over 2, 2 over 3, 3 over 4, blah, 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 such that the nth term is n over n plus 1, what is the product of the first 19 terms in the sequence? So the mistake here would be a student just typing in 1/2 times 2/3 times 3/4, etc., rather than seeing that with multiplication you can cross off like numbers in the numerator and the denominator. We discussed it with the SAT, but it's worth talking about what educated guessing really means, since the entirety of the math section is multiple choice. Really what educated guessing means is if you really have no clue how to do the answer, you've at least eliminated some of the questions. So you're not just, it's more than a 1 out of 5 chance. If you can eliminate 2 options, your odds have increased, and every point counts. And educated guessing versus just random blind guessing, there is there's a net of 3 or 4 points there that can make all of the difference. It's worth noting that, let me fix that. It's worth noting that each question is exactly the same. So if a student is missing question 1, or if he misses question 60, his score will be affected in the same way. So because of that, you have 60 minutes to do 60 questions. The student should be focusing the most on questions he knows how to do. So a lot of the time, with this test in particular, a lot of practice time is well spent in helping a student figure out sort of a binary, okay, I've read the question. Do I immediately know the path to solving this? Yes or no? If yes, do it. If no, circle it and come back. This is what I did when I was taking tests. Whether I wasn't sure how to do something immediately, or if I knew, okay, this is going to take a little time to figure out, I would skip it and go back and come back after the fact, because using this method allows the student to get through the entire test, to see every question, and to be able to map out, okay, I can do this, and then do it, or I need a little extra time, and they can work that into how their time management. So the main math problem solving strategies for the ACT are the same as the SAT, as they are for most standardized tests. Back solving, like we discussed, is when there are the answers are numbers, and you can plug those numbers into the question and sort of take them through the ride, divide in half, add 30, whatever. You can't use back solving when there's variables. And as we discussed with the SAT, you can use the structure of the question, since they are often listed from least to greatest, by starting in the middle. Because if you plug in that number, typically it'll be clear if you need to go higher or lower. And so it's creating 2 pathways for you, rather than just starting at A and going A, B, C, D, E. So because the ACT has 5 options, it makes sense to start with that middle term, which is either C or H. So A, B, C, D, E, and then typically F, G, H, I, J. The other strategy is PIN, which is basically verbatim in its applications across the tests, particularly with the ACT. On word problems with fractions in the answer choices, you can often plug in a number of the original quantity. So choose the largest number. Hi, Kayla. Sorry about that. Okay, let's dive right back in. Okay, so we were discussing PIN more or less manifests itself in the same ways across both tests. particularly on the ACT, if there's word problems with fractions in the answer choices, you can often plug in a number for the original quantity. And you should choose the largest of the denominators for the answer choice. That will often provide the best results for those types of questions. And if you see questions that have which of the following or something must be, you can often use PIN to get the right answer, but you'll typically have to plug in more than once. And just as a reminder, when you do have to do PIN more than once, you want to try and do different numbers. And by different, that means either fractions, 1, negatives, or 0. So diving into the concepts, there is quite a bit of carryover between the two exams, but starting with pre-algebra, the number properties, the students should know the definitions of integers, rationals, irrationals. Again, the questions are rarely going to be which of these is irrational, but the student needs to know the difference between a whole number and a natural number because the questions are going to throw that at them. In terms of concepts, they should be comfortable with even and odd rules, divisibility rules, primes, prime factorization, the difference between factors and multiples, absolute value, exponent rules, roots, fractional exponents, logarithm rules, simple arithmetic and geometric sequences, and matrix addition and subtraction. I know some of these concepts like matrix addition, subtraction aren't pre-algebra, but the math that you have to be able to do to get those questions right for those concepts are rarely ever more difficult than the pre-algebra applications of them. So in particular, back solving often works great with GCF and LCM questions. And as a reminder, like from the SAT, if you're looking for the largest choice for GCF, you want to start with the largest option. For LCM, you want to start with the least and work your way up or down. So for pre-algebra with applied arithmetic, the concepts they need to be familiar with are arithmetic mean, median mode, ratio problems, rates, word problems involving percents, involving percent change, simple applications of probability, simple applications of permutations and combinations. They should be able to deal with word problems sort of with groups, Venn diagram questions. So like if you have 20 kids at a camp and 12 of them do baseball and 14 of them do soccer, what's the overlap or something like that. They should be familiar with graphs, particularly pie charts, bar graphs, line graphs, and pictograms, frequency charts, and sometimes they do ask logic questions, which doesn't necessarily come up in a student's typical curriculum, but it's rarely, if A, then B type of questions. And the ACT likes to ask specifically about the contrapositive. So if A, then B, then the contrapositive of that is if not B, then not A. So it's the negative reverse of the logical statement they give. Some of the other logic questions involve inferences. On these questions, the job is to find the answer that must be true or the answer that most clearly leads to a given conclusion. To eliminate wrong answers, get rid of any answer choices that introduce new info, contradict the given info, or if they're strongly worded, going beyond what is presented in the question prompt. So I don't want to make too big a deal out of logic because there are rarely that many questions on them, but that is one of those concepts that students predictably haven't seen. And these little tips should address most of the types of logic problems they would see. So getting into elementary algebra, it's quite straightforward. It's an Algebra 1 curriculum. They need to know the different terms, coefficient and constant, and all the definitions related to algebra. They need to be comfortable with simplifying expressions. They need to be able to evaluate them, to solve with one variable, to solve with multiple variables. They have to work with inequalities, and they have to remember when the signs flip. They have to know how to factor equations. They know how to solve quadratics. The ACT in particular loves asking questions that require them to recognize common quadratics. So it might be a perfect square multiplied by a factor. It might be difference of squares. but if the student is familiar with the patterns or has memorized them, that will definitely help save time. That should be the incentive, particularly with the ACT with your students, is that since it is a time test, it is to their benefit to put in time now to memorize formulas so they can save time then. That's sort of the bargaining strategy that I've found to be most helpful when my students are resistant to memorizing formulas. And then they are also required to model algebraic equations. Getting into intermediate algebra, that's again code word for basically algebra 2. They need to be able to solve equations and inequalities involving absolute value. They should feel comfortable solving systems of equations with the various strategies. Direct and indirect variation questions come up both as word problems and graphs. The special case quadratics, as we discussed, knowing the quadratic formula is incredibly helpful for the ACT. They will have to be familiar with radical and exponential equations and then growth and decay problems. They'll see imaginary and complex numbers, which can involve conjugates and things of that sort, but it usually isn't too crazy of applications. What I mean by symbolism questions are the test will create a function defined by a symbol. So it'll be diamond for diamond equals n squared plus 4 over n or something. And so then they'll give you a different parameter to plug into that function. And then you have to be comfortable with functions and the composition of them, so f of g of x and things of that sort, as well as functions of two variables, so which is rarely seen on the SATs. So f of x of y, so they'll give you 2 points that you need to plug in, and then they'll ask for the domain and range of all of those types of functions. Plane geometry will cover lines and angles and degrees in a circle. So they'll take a circle and they'll divide it up in a bunch of ways with a bunch of variables, and they'll want one specific sector of it. The relationships of parallel lines, the various different types of triangles and their definitions, special triangles like 30, 60, 90, and 45, 45, 90. So x root 2 for 45, 45, 90, and x root 3, 2x for x, or for 30, 60, 90. As well as the relationship between similar triangles, which is that you can, if you align the corresponding sides of triangles, you can set them into ratios and set them equal. The ACT loves to ask questions about the triangle inequality theorem, which is something students might not have learned or might not have learned with that name, but it's basically the rule that says the largest side has to, or it's the rule of the relationship between the three sides. So they'll give you two sides of a triangle, and they'll give you options of, which of the following could not be the side. So you always have to consider, what if the side I'm looking for is either the largest or the smallest, and that will encapsulate all of the potential answers you can have. Moving on to quadrilaterals and other four-sided shapes. It isn't necessary to... I find that it's helpful for the student to remember the difference between all of them if they do remember the formula. A question isn't usually going to be so bald as what is the, find the area of this rhombus. But to know the difference between all of them and why they're different is inherently linked to the formulas that are relevant on the test. And they should know the different types, not just trapezoids, but what's the difference with an isosceles trapezoid. And if they know some of the formulas for regular polygons, like what is, the sum of the interior angles of a polygon of side n or something like that. With circles, they need to know the corresponding parts: diameter, radius, circumference, area. They need to know the difference between what a chord is, what a tangent line is, and then the various relationships of inscribed triangles in semicircles and in a full circle, as well as how to calculate arcs. and the central inscribed angles and their relationships, as well as calculating sectors. They'll also need to know surface area and the volume of solids, which I found that for surface area, if you can, most of the formulas can be described as 2b plus pH, so 2 times the base of this three-dimensional object plus the perimeter of the base, which, if it's a circle, is circumference, times the three-dimensional height. If the student can work with that formula or something, one of its derivatives, rather than memorizing every single type of shape, I find that that is a good way of reinforcing the primary concept, as well as saving some time and effort. Finally, with plane geometry, they will need to be able to calculate the areas of shaded regions. So let's say you have a circle inside of another circle, or a square in the circle, or something like that. And then it will often manifest itself as a geometric probability. So if you had an equilateral triangle that was cut up into smaller triangles and part of it was shaded, you would have to be able to count them up and put it over the total number, those types of things. Coordinate geometry is really just, graphs of linear equations and a lot of the stuff we've seen in Algebra 1. They'll need to be able to find length of line segments. So although they don't need to memorize the distance formula, I find that it's helpful to, for them to conceptually understand what they're doing. Also calculating midpoint and slope, knowing the difference between positive and negative. It's very important, like on the SAT, that they can go between the different forms of linear equations. So standard form, point slope form, and slope intercept form. To know the algebraic relationships of parallel and perpendicular lines, as well as intersecting lines. They'll have to graph inequalities. They'll have to look at graphed systems of inequalities, and so forth. They'll have to be comfortable with quadratic functions, parabolas, whether it goes up or down based on the algebra, or whether the equation is positive or negative based on that information. Again, vertex of parabolas is an incredibly important concept. Negative b over 2a is the fastest way of dealing with that, as opposed to completing the square. So there are plenty of students who haven't seen that or don't remember covering that formally in their Algebra 2 class, but that's one concept that I think is worth you introducing to them if they haven't seen it. The test does cover more conical concepts than the SAT. So you are going to see circles like on the SAT, but you will also see ellipses. You might also see square roots, logarithmic graphs, hyperbolas, and higher degree functions. But on these questions, it's mostly about matching a graph with an equation. And even if they aren't familiar with what a quartic graph looks like, you can always work backwards and plug in values and find which answers work out. They'll also be required to shift these functions, and they will see rotations and reflections, which might not be straight up line graphs, but they might be shapes on the coordinate grid. And it asks, what would a 90-degree counterclockwise rotation look like? And then there'll be a bunch of pictures to choose from. And finally, the last section, concept section, covered on the ACT is trigonometry, which it does go into more depth than the SAT, but it's not the same difference of spread, whereas geometry is a far larger part of this test. Trigonometry, there are predictably more questions, but it's sort of 7 compared to 4 or 5. And so though there are more questions on it than the test, it doesn't get appreciably more difficult than the SAT trig, I found. It's not getting into double angle formulas and the real pre-calc concepts. It's reviewing SOHCAHTOA and asking if they are familiar with reciprocal functions. There are applications of law of sines and cosines. Standard position, starting from the x-axis and moving counterclockwise. A mnemonic that's helpful with a lot of these questions is all students take calculus, which A is in the first quadrant, which means that all of the three primary sine, cosine, and tangent are positive in the first quadrant. Students is the second quadrant, which means that sine is the only one that's positive in quadrant 2. T means that the third quadrant, which is the bottom left, is tangent is the only one that's positive there, which makes sense because negative sine over negative cosine would be positive tangent. And 4, C, all students take calculus, means that quadrant 4, directly below the positive part of the x-axis, is cosine is positive there. They need to be comfortable going back and forth between degrees and radians, pi over 180, 180 over pi. And the more familiar they are with the unit circle, just in general, but with all of these questions, it'll just make their lives easier. The unit circle is often a concept that students don't like, whether it's because their teacher isn't the best at teaching it, but for the sake of this test, it is particularly useful to use that as one of your primary tools for trying to teach the kids trig or help them refresh. With respect to graphs, they really won't have to worry much about tangents or the reciprocals. It's really just straight up sine and cosine graphs, where they'll be asked about period and amplitude, which is a reminder 2 pi over b equals period when thinking of the trigonometric equation. And then they'll be asked to solve trig equations. So that is sort of an overview of the ACT math section, which again is different from the SAT because it is only one of 4 sections as opposed to half of the entire test. The ACT is more time pressured, and it seems to cover a wider expanse of mathematical experience. However, similar to the SAT, those upper level concepts are usually surface level questions rather than typically the hardest questions on the test will be harder from easier or further in the past concepts that have been seen. So with that, thank you guys for joining me, and I look forward to seeing you next week to discuss the science section.